right, how are we doing today? Good? Everybody still awake? Okay, very good. People are making their way back. Okay, well, I'm Nate. I'm a machine learning hacker at Hugging Face. And today I'm going to give you a kind of a two-part talk. The first part of the talk is going to be about Hugging Face, what it is, what we're about, some things you might not know about Hugging Face. And then in the second half, we're going to build a Gradio app. And you're going to see how that works and see how easy it is to build machine learning apps with Gradio. How many of you have heard of Hugging Face, by the way? Just show of hands. Okay, great. Okay, awesome. Helps me to know. Okay. All right, so this first part of the talk is 19 things you don't know about Hugging Face. We're going to breeze right through this because I want to get to building an app. Yeah, this is me. Not too exciting, but there I am. There's my mug shot. So yeah, the first thing about Hugging Face that you should know is that we're here to democratize good machine learning, and we do that in a few ways: open source, community, and ethics first mentality. So open source is a huge thing for us. We want to make sure that we're building with the community. The second thing is that, like I said, is we have this sort of ethics first mindset. So we have a group for our ethics and society group at Hugging Face, and this drives a lot of how we think about things and what we're building. Another thing you might not know, or you probably do know, is Hugging Face Transformers is one of our big libraries, but we also have a variety of other machine learning related libraries and tooling these are all popular open source projects. So diffusers, data sets, tokenizers, the TIM library, as well as all these other ones that you see here. So some of them for parameter efficient fine tuning, et cetera, et cetera. Another thing you might not know is that diffusers, our diffusion library, is actually growing faster than transformers, which is like our, the library that most people know us for. So it's kind of taking off like a rocket here. So we have a cute little hugging rocket emoji here. We have over 200,000 free public models on our hub. So if you go to Hugging Face, you can search for all these models. And there's over 200,000 free public models that you can go check out and see if they work for your use case. So instead of going and trying to build a new model, you might want to go check and see if somebody's already done it on our hub. So that way, you can just take it and run with it. Over 50% of the models on our hub are actually private. So a ton of the models, there's a ton of models on there that you're not seeing. So if you don't want to necessarily share your model publicly, you can always use our hub privately. We have over 1 million model downloads per day. So people are really using the hub. These models are very widely used across a wide variety of domains. It's not just NLP models that, a lot of people know Hugging Face for NLP because of transformers, but we cover a wide variety of domains and modalities at Hugging Face, as well as a bunch of different machine learning libraries that things are compatible with. So it leads to a lot of downloads per day. The number one question I think I always get asked whenever I go anywhere with Hugging Face is, how does Hugging Face make money? Here's a couple ways that we make money. One is through compute, so we sell access to compute through Spaces. Spaces is our sort of hub of machine learning demos. So we have demos that you can build, and we're going to build one later. And then, if you need access to accelerated hardware, we can do that for you. Another way is through expert support. So we have some of the best machine learning engineers in the world at Hugging Face. And if you need help with a project that you're working on, you can reach out to us, and we'll help you out. A great place to start if you're not a machine learning practitioner is our tasks pages. So if you go to huggingface.co/tasks, you'll find an overview of all the big tasks in machine learning. So ranging from things like image classification and text classification, which are pretty well known, to things that you might not know, across vision, natural language processing, and other domains. We also have a JavaScript library. So we're not just working in Python anymore, but we also have a JavaScript library that allows you to make predictions on a wide variety of models, over 100,000 different models, right from JavaScript. And actually, this is free. So you can go and use this API for free and do whatever you want with it. And if you're a web developer, this is great because now you don't have to learn Python in order to do the machine learning part. We have a free diffusion course. So if you're interested in diffusion models, we have a free diffusion course, which you can go find on our site. Well, it's actually on GitHub. So if you just search Hugging Face diffusion course, you'll find it. And it's a free course. We have an implementation of fast control net. So this is a diffusion model that allows you to sort of control how the images are generated. So here you can see that we're sort of doing that here with this picture of Taylor Swift, it seems. But yeah, there's also a Mac app for diffusion. So we built the app. If you want to be able to create images from text, you can use this free Mac app through the App Store. Another thing that we do is we have a group of scientists that we work with that we work on open reproduction of state-of-the-art models. So it's a big trend right now that models are becoming more and more closed, and these models are getting better and better. But something that's really important is that we're able to reproduce this research and be able to give it away for free, because the more that models are closed, the more the disparity between the haves and the have-nots increases, right? So we want to make sure that everybody has access to state-of-the-art machine learning. I think that's the best way to reduce biases and reduce the gap in machine learning. We have a gigantic model here, 176 billion parameter open source large language model that's been fine-tuned for chat. So you can check that out. It's called BloomZ. Bloom was originally trained on a French supercomputer by folks in the Big Science group, which we're affiliated with. So yeah, there's also over 30 open source large language models on the hub. I would say the number is actually significantly higher than that. I think we kind of filtered for this slide. But these are some really great ones. I think I want to make sure that the one that I really like is on here. Yeah, there's a new one called Falcon 40B, which is really quite good. It's been beating GPT-3 on some benchmarks. So I highly suggest going to check that out. It's Apache 2.0 license, so it's completely open source and available for you to use. Another model that we just dropped, and we dropped it a couple weeks ago, and then immediately it got beat. But it was the state-of-the-art in large language model, the state-of-the-art large language model for code generation. So if you're thinking Copilot or something like that, this is an open source implementation of a model like Copilot's model. So and we also have folks that have created extensions. So if you're using something like VS Code, you can actually have an open source code completion model right inside VS Code for free. Another thing we just released is Hugging Chat. So there's other very popular chat applications out these days that I'm sure we all know about. And Hugging Face has now an equivalent that is using just open source models. So if you want to go try a open source model chat, you can go do that. It's 100% free, and the models are 100% free and open source. So if you'd like to try that out, and then if one of them works for you well, you can go ahead and use that for whatever you want in your business. And again, these things, because they're not being sent over an API, your data stays private. And as these models get better and as more models are released, we'll continue to add these models, the new models, to this Hugging Chat's interface, and you'll be able to use the state-of-the-art in open source chat whenever you want for free. The last thing is that we just released our own implementation of agents, the Transformers agents. So using the Transformers library, you can now use agents. We have developed a variety of different tools that you can use, which leverage transformers, diffusers, and a bunch of other different open source models. The implementation is a little bit different, but I think it's a little fun. Yeah, go check it out. It's quite new, so it's bleeding edge. Now, before I transition to the other part of the talk, I just want to mention real quick plug for MindsDB. This is how you would use MindsDB to connect a Hugging Face inference, connect to the Hugging Face inference API. So you just provide your API key from Hugging Face, and then establish a model, and then you'll be able to predict using those models for free. Yeah, so that's how you do it. So in this case, it's a text classification model. All right, so I really breezed through those slides. Is everybody still with me? Good? Okay, great. Okay, excellent. So we're moving on to the second part of the talk here, which is building apps with Gradio. I'm really a huge fan of Gradio. Has anybody used Gradio in the audience before? Just quick show of hands. Okay, great. That's what I wanted to see, because now I get to introduce it to you, and you're going to be very hype. It's going to be great. Okay. All right, so why demos? So demos, why would you want to demo a machine learning model? Well, the first reason is that it makes it a lot easier to share with people, right? So now you can share your machine learning model and what it can do and its capabilities with a wider variety of people, right? Another thing is to prove the reproducibility of your research. So if you're saying that your model can do such and such, you want to be able to prove it. And one way to prove it is by providing somebody with a demo. Show me the money, right? And yeah, it's a great way to prove that your model does what you say it does. And third, I think the most important thing is that allows a diverse group of people to be able to try out your app and poke and prod it and see, what its limitations are, what its biases are. And this, makes model development so much better, right? If just machine learning engineers are the ones poking and prodding the model, you are definitely bound to be missing issues with your model. So getting a wide variety, a diverse group of folks to be able to try your model is key. Oh, and I have now a little GIF here that is demonstrating the app. Okay. So how many of you have actually tried to build a demo around a machine learning model before? Anybody? Yes. Okay, how was it? Was it good? Yeah, usually what happens when you try to build a demo around a machine learning model is, you're like, okay, I've got this model. I'm very excited. We're going to build something awesome. And then you realize that you have to learn HTML, JavaScript, CSS. You have to create this, good UI, UX, and that takes a long time. And then, you sort of give up. So, and you cry, and you're at your desk for hours and hours and days, and yeah, you fail. So the old way to build models, to build demos, was you would be training your model in PyTorch or TensorFlow or something, or whatever, or scikit-learn or something, and then you would you need to containerize and deploy the model using Docker, Flask, some sort of maybe some cloud thing. You need to maybe have a database, maybe through MySQL, and then you'd have to build this interactive user interface with a good UI UX with HTML, JavaScript, and CSS. And so by the time you're done learning all those things, your model's completely obsolete, because we know that models, these models are like good for a week and then there's a better one out next week, right? So this is too slow, right? So the new way to build demos is, train your model in whatever, in Python where you're comfortable, and then use Gradio to build an app around it. Gradio handles everything. It handles the, building a nice user interface in Python, something that you're used to using. It makes it extremely easy to deploy, and yeah, you're just going to have a good time. So Gradio, this is sort of the typical usage. I think I have a GIF here too. Okay, great. So this is how it typically looks. You sort of import Gradio. You define a Gradio interface, and this interface takes 3 ingredients. The first ingredient is a function. So here in that case, it's classify image. That's some Python function. And all we're doing is wrapping a Python function with an interface. So we have a function, and then we declare the inputs and the outputs of that function. So in this case, this function is expecting 1 parameter, and that's going to be an image type. And in this case, we use sort of a shorthand with a string. And then you declare the output type. So in this case, it can be a label. And you can do this from a shell. You can do this from a Jupyter notebook. You can do this from Google Colab. All of them work, and you'll get a nice, beautiful user interface right wherever you are. So it'll work locally. It'll work in any of these cases. So yeah, now you have a demo, right? I have a demo, great. But now it's just me using it, right? So what would really be helpful is if you could share it with other folks, right? So what we did is we made Hugging Face Spaces. So Spaces is this place you can go to browse, try out, and share your own machine learning demos. So you can see all these like sort of tiles here are different machine learning demos. And I just took this screenshot, I think, last week. So you can see these are sort of like up-to-date, cool demos that you can go check out. So you can go to hf.space, or you can go to hf.co/spaces. What's cool about this is that by sharing your machine learning demos, we're now at a place where machine learning demos can go viral, right? I think we all have seen this. These slides are a little bit old. I've been using them for a while, but I think a greater example is probably ChatGPT, right? ChatGPT was like the first, one that went supernova level viral, but it's a machine learning demo, right? And now folks are actually interfacing with AI, and for the first time they're seeing they can get like something really cool out of it, right? On Hugging Face Spaces, the first example of this was this anime GAN. So what this did is it would take an image of you and it would try to turn you into an anime character. So folks really loved this on Twitter, and it went really, really viral. A bunch of people were changing their Twitter profile pictures to anime characters, and it sort of went, it got big. And what's great about this is that, we're at this turning point in machine learning where it's going from just the machine learning practitioners, just the engineers, to being anybody who can use a GUI or web browser. Your grandma could use it, right? And that's incredible. So yeah, we love that AI is becoming more accessible, right? So what we're going to do now is if you have a laptop out, if you don't, you can follow along. It doesn't matter, and we can share this link after. It seems like this is, it'd be a little bit difficult for you to break out your laptops now. But if you have one, you can go to this link, and we're going to walk through this demo real quick, and we're going to build an app ourselves. So if you have a laptop, I'll give you a second, and then we'll kind of move on. Everybody still with me? You good? Having fun? Okay, great. I see a few people rummaging, so give me a second. What's up? There is Wi-Fi. It's up at the front. Really great question. But you can just follow along too. It doesn't matter. Like, it's okay. I'm gonna run it either way. You can be lazy if you'd like. It doesn't matter. And even if you're not a Python programmer, I think you're going to find that generally you'll be able to tell that this is sort of easy, which I think is the beautiful part about it. And what time do I have, by the way? Where am I at? Okay, great. Okay. Is everybody good? Should I leave this up for another minute or so? Good. Okay, nobody's yelling at me, so I'm just going to open it. Okay, am I on the Wi-Fi? I am. Okay, excellent. So we're going to open up this. This is a Google Colab notebook. Google Colab is like a Jupyter notebook, but in the browser, it's like Google Docs for code, right? So this is a shareable notebook that anybody can run in the cloud for free, and that's what we're going to use. So we're opening it up here, and you see a lot of text. And like a good programmer, what we're going to do is we're not going to read anything. We're going to just continue to scroll. Okay, so we're going to scroll past all the information. I'm here for you, don't worry. And we're going to scroll down to this very first cell here, the cell that says pip install quiet Gradio. And what this is going to do is it's going to allow you to install Gradio. So to run it, you can hit the little play icon here. Also, can you read this? Should I make it a little bigger? Okay, that's cool. We're going to hit this little play icon, or you can do like shift return on a Mac or shift enter on a Windows computer. Okay, so I'm going to run that, and what that's going to do, oh yeah, and I'm not Google, so just hit run anyways. I promise there's nothing nefarious going on here. Beautiful, so we'll give that a second to install, and then afterwards we're going to scroll down here to take a look at our, what we're doing. So when I mentioned Gradio earlier, all it does is it wraps a Python function. So you write a Python function, and we're going to wrap it with an interface, okay? So we're going to write first a function that will apply a sepia filter to an image. Now, you do not have to know how this works, okay? But we're basically just going to be getting a matrix that represents the image, and we're going to multiply it by this, and then that's going to produce a sepia filter on the image, which is basically going to make it look kind of brown. So nothing too exciting. Don't worry about how the code works. You don't have to worry about it. It's like a little NumPy magic here. But that's all we're going to do. And to define that function, we have to run this cell. So again, it's just going to be return enter. You can hit play on that play icon up there. So now that we've defined our function, we're going to define our Gradio interface. And again, this Gradio interface takes 3 ingredients. The first is that function that we defined, so sepia is the name of the function. Then we're going to define the inputs. So the input here is going to be image, because we want an image type. And this is a shorthand. I can kind of answer questions about that in a bit. You'll see in the next example what I mean. And then you define the outputs, which again is going to be an image. So in this case, we're going to return a NumPy array, which represents the image. And I don't know who put a semicolon here, but I'm going to get rid of it just for my own sanity. And then when we run this cell, what it's going to do is it's going to launch a Gradio app right here in Google Colab. So if we give it just a second. And boom. And oh, there it is. OK, it's coming. Yeah, so now we have a little interface. Great. So on the left here, we see this is our input component, which is going to be an image. And then over here, we should get our output if it works. So I'm going to pull up an image from my computer. Let's do this one, which I think was my, yeah, there's a little ad for me being here today. So you're seeing an ad. And we're going to hit submit. When we hit submit, it's going to run this image through our function that we defined, and we're going to get an output for it. So if all goes to plan here. Sometimes with some networking, we'll see if there's an issue here. You shouldn't be taking 13 seconds. Come on. Do it. Do it. I've never had it be this slow. Okay, well, that's rough. Okay, there we go. Beautiful. Okay, so now I got a little, I promise you it usually takes 1 second. But yes, there I go. I'm sepia-fied now, so like it's kind of turned a little gray. And yeah, so you saw how easy that was, right? We have a function, we define the inputs, we define the outputs of our Gradio interface, and then it creates this little interface for us right in Google Colab, so we can use it right away. Now if we scroll down, we're going to take a look at a little bit more involved example. So in this case, when we scroll again, just don't read anything, you're good. We're gonna import NumPy again, import Gradio again, and we're gonna write this function called generate tone. Now generate tone is gonna take in 3 parameters this time, so not just 1, we're now gonna take in 3. The first is gonna be a note, so there's gonna be a note on a keyboard, the octave of that note, and how long that note should be playing in seconds. And then we're gonna use NumPy. Again, don't worry about it, just completely forget about how that works. But we're gonna use NumPy to sort of create an audio array that will represent some note that we'd like to play. It's gonna be a sine wave. So that's all it does. And when we return it, we're gonna return the sampling rate, because you have to know what the sampling rate of the audio is, as well as the audio data array that we're creating in NumPy. And if we scroll down, we can take a look at what the interface is that we're gonna define. So this time, instead of just 1 input, we're gonna have 3 inputs. So all we do is we define a list this time. So to make it clear, we're passing a function, which is our generate tone function, which we're defining here. We're going to define some inputs, and we're gonna define some outputs. Beautiful. In this case, the outputs is gonna be the shorthand. But you can see what the shorthand, like, because before we were using the image shorthand, now we're actually going to be defining these using Gradio. So instead of the shorthand, you can also just call the classes. So this is a Gradio dropdown. So we're going to have a dropdown for the notes. We're going to have a little slider for the octave, and then we're going to have a number for the duration that you'd like to have in seconds. So this is just sort of an example to show you a few different components that you can use. There's a ton of different components in the documentation. Actually, I'll just pull that up real quick. Gradio.app/docs. If you go here, if the Wi-Fi wants to cooperate, and while I'm doing that, I'm going to run this just because we'll see if the Wi-Fi is being slow. Okay, so yeah, if you go to the Gradio docs, you can check out all the different components that you can use. There's a wide variety of them for basically every use case you could possibly want, and you can also define custom components using HTML, which is great. So let's go back. Let's see if my Wi-Fi is cooperating. Let's go. Come on. Oh yeah, another thing I want to mention is that you can also add a little title or description to your app just by providing those keyword arguments. So in this case, we're going to add a title called generate a musical tone. And when that launches, come on. Okay, beautiful. Okay, so what I'm going to do now is I'm actually going to, well, let me just make sure you saw that. So we have a note, which was our dropdown that we defined, right? Dropdown, we have a slider, and we have a number, right? So here's our slider for the octave of that note, as well as the duration in seconds. So I'm going to change it to like 3 or something. And then I'll pick a note. Let's go with A. And then when I hit submit, oh, look at that. It went fast that time. Great. Okay. we get an output component of audio. So yeah, so if we play this, let's see. I'm not sure if it's going to play through here or where it's going to play. You heard that? Okay, great. So we generated a tone. Great. Yes. Mind-blowing stuff, guys. Mind-blowing stuff, yes. This is AI. So, but you can imagine, right? This is a simple example, but you can imagine all the different things that you could do within this function, right? You could do anything you want. You could do, you could put a machine learning model in there and make predictions, right? You could define, your model above the function, so the model's defined, and then when you write a function, you can just sort of use that instance of that model, right? And be making predictions. And again, this works beautifully right here, but it also works, on your local machine. It'll work. It's easy to deploy, and you can also deploy it on Hugging Face spaces, which if I have the time, I will do, but we'll see. Now I'm going to continue on. Another thing we saw earlier about the inference API. So we have a free inference API, which sort of cold loads a model on it basically spins up a Docker image, and it'll serve these models for free. So one of these models that's compatible with this is this fast speech model, which should be a text-to-speech model. But there's a wide variety of different models, for code generation, for text generation, for all sorts of different things, for image generation from text. But with Gradio, there's like a little helper function called the interface.load function, which will allow us to point to one of these models that's on the Hugging Face hub and load it and create an interface around it in one line of code. So we're going to give that a try right now. And sometimes this works, sometimes it doesn't work because the API has to load. Basically, the Docker image will shut down if it's not being used. So if it is being used, this will run really fast. If it isn't, then it's going to have to sort of load. But we'll see. So I'm going to do I am Nate, and I am teaching a class on machine learning. And we're going to hit submit. And what this is going to do is it's going to hit this model on the Hugging Face hub. So let me show you what I mean. I'm going to go to hf.co. co/this. Great. So if the internet will cooperate. Yeah, so here we can see the actual model on the Hugging Face hub. So again, if you're not familiar with Hugging Face, it's basically the GitHub of machine learning. So this is a model repository. So in here is where all the model assets are stored. So the model weights and things like that, configuration. And the most important part here, which we're looking at, is the model card, which is basically a readme.md file in your repo. It's probably the most important part of your model repository because it lets people know what your model actually does, how to use it, what its biases are, what its limitations are, and this is huge. But yeah, so this is the model that we're going to load. And if I go back to our app, it should. Okay, you didn't really hear it too well. For some reason, I can't turn up my volume. But yes, it works. So I am Nate. I'm teaching class machine learning. Did a little text-to-speech thing here. But this works for a wide variety of different models on our site, right? I think it's like something like 100,000 different models it'll work for. So yeah, it can be really convenient to use this. Now, if I have time, I think I do. I have 10 minutes, right? 10 minutes, I think. Okay, great. So I'm going to just show you real quick how you would actually create a space, a Hugging Face space with Gradio. So if I go to spaces, you can see these are like sort of the spaces that we've highlighted for this week. These are the 8 hottest apps right now. There's also the most recent ones, so we can kind of scroll down and see some of these. But if we come into here and you're logged into an account, you can create a new space. So I'm going to create a new space, and mine's going to be under my dog account here. And I'm going to call this one MindsDB Demo. And I'm going to give it an MIT license. I'm going to select Gradio as my SDK. You can also use Streamlit if you're familiar with Streamlit. You can also basically do anything because you can use Docker. So you just basically define a Docker file, and we will host that for you for free. If you just have an account, you can host it for free on a CPU machine. So I'm going to select the free compute instance, which is the CPU one, and I'm going to set it to public. So we're going to create that. And what this will do is it'll create a new space repository for you. Again, it's just a Git repository. And when we create that, all we have to do is we have to go to the Files tab here. You can do this, you can clone this locally and however you would normally do it with Git. But in this case, I'm just going to do it through the browser because we're going to try to move fast. And I'm going to create a new file. And app.py is the name of a file that is sort of reserved. It's looking for a file called app.py. You can change this in the configuration. But if you define a file called app.py, it'll try to launch an app out of there, either your Streamlit or your Docker app. And if I go back to Colab, I'm going to steal some code for myself. Let's see if we can do, we're going to do this sepia one, I think. So I'm going to grab this code here. I'm going to come back. So I'm just going to paste this stuff into the file. So we need the Gradio definition, and we need the interface, which we're going to do here. I'm going to paste that there. And I'm going to put this down below here. Great. And when you call .launch on the instance, it starts the app. So it should work right out of the box when we run this. So I'm just going to commit this new file. And if I'm a good programmer, it should work. What's going to happen now is it's going to build your app. If you go to sort of those logs tab, you should be able to see the logs for your app. This is it building a Docker container and then launching your app. So it looks like the app just started. And if we give it just a second, it should be running. OK, great. If we switch back to the app tab, we now have oh, we have our app. Great. So this is the same one that we were using in Colab, but now it's hosted on Hugging Face Spaces. So now what's cool about this is you can go to hf.co/spaces/dog/mindsdb-demo, and you will also be able to use it in the browser right now. Or you can send it to your grandma if you haven't made an app for your grandma. Who knows? But yeah, what's beautiful about this is now you can share this app with the community. You can do whatever you want with it, yeah, it's really helpful. You can also make sort of private ones. Or you can do them through your organization, which you can sort of collaborate on these, which is great. Yeah, I think that's about it. I really breezed through it because usually I do this talk and there's like active questions, but because you guys weren't allowed to ask questions, I went for it. Yeah, at this point, I think I'm open to any questions if I have time. If not, then yeah, I think I have 8 minutes, right? Yeah. Beautiful. Thank you.
Thank you very much. So opening up to questions, and some are going to come through on the live stream pretty quickly.
What's up?
What kind of feedback support tools are you baking? So I feel like you could demo it, but what if I want to actually collect feedback?
Sure, yeah. So the question was, what sort of feedback mechanisms are built into Gradio? Into the spaces, or in spaces or to Gradio? Okay, yeah. So I believe there's a flagging mechanism. I think you can turn it on, and that will allow you to allow users to flag bad examples. This might have actually been removed. I'm out of touch with whether it has or hasn't been. But one awesome feature for feedback, though, is our community tab. So if you see here, there's a community tab. And if you switch to that tab, it allows anybody to, similar to GitHub issues or GitHub PRs, allows people to come in here and report issues about the model, ask questions about it, etc. You can also, if you go back to the app, well, actually, you didn't have to, but if you click this 3 dots here, you can also report the space. So if there's an issue with it, or if you want to report that it's not working to the developer, you can do that there. Yeah.
There was still a flag button.
Oh, okay. Yeah, well, yeah.
If anyone has questions, I'll bring you a microphone, so just hold your hand up until I come to you.
Okay.
We'll start over here.
I love how simple it is to bring up a simple interface. Is there 2 questions? One is, are there styling options? Can you style this with CSS and control the look of it so it's prettier? That's the first question.
Mm-hmm.
And then second, if you could briefly compare and contrast Streamlit with Gradio.
Sure, absolutely. These are great questions. The first one is, how can you stylize it and you'll make it your own? There's a couple different ways. One is that you can actually use CSS in any of these components. So if you come to any of these components, you can provide a CSS keyword argument, and that will alter the look of the app itself. Now, what you can also do is, and this also works from like a CSS file. Another thing you can do is you can use Gradio blocks. So the way that I was showing you is just through the function, but you can sort of compose apps however you'd like and have complete control over how the app looks. And then if you use CSS on top of that, or custom HTML, you can make the app look exactly how you want it to. Now the other question was, what's the difference between, the core difference between Streamlit and Gradio? And I would say the core difference is that Gradio is meant to do inference, so like on machine learning models. Specifically, the issue there is if you've ever built a machine learning app, you probably have run into the issue of a queue. So if you have tons of people using your app at the same time, you need to make sure you manage that queue, right? And Gradio does this for you. So if 1,000 people come and use your app one day, they're going to be added to a queue, right? So let's say your model can only support 1 request at a time. It'll handle that for you. It'll handle that queue for you without you even thinking. So you're not going to blow up the GPU and then your app's going to die. That's not going to happen, right? So it's going to manage that queue for you, which is a beautiful thing. Yeah.
How can you enable private?
Sure, yeah. So there's a couple different ways. If you're in an organization, you can create an app through your organization account and make it private to your organization. Or like, for example, if you're just using a normal user account, you can come and change the space visibility and make it private. This will be then private to you. So yeah, actually, I think the organization is probably the best way to go. So you create an organization, and then you create one that's private to everybody except for those that are in your organization. Yep. You can just ask it. I'll repeat it. Go ahead. Sure. Yeah. So it's not going to replace a SQL database. So there's not like really a SQL database piece. Yeah, but it does. Yeah, it's not going to replace a database. So if you still wanted to hit a database, you would just hit it through the function. Yeah. Does that answer your question? Okay. I believe there are capabilities for that. Let me see. Oh yeah, sorry. Does it work with IoT devices or signals? Right. I believe it can. Yeah. So in what capacity? How would you like to use it? Like perhaps. Oh, interesting. Yeah. So if you can make it if that signal's like a file, that would work. If it's gonna hit something else, then maybe you have the function send that signal to wherever it needs to be, right? Because otherwise you're just gonna get like sort of a signal back, so you can get like basically a file or yeah, an array back. Yeah, you'd be able to handle that through the function. It would still do all the queuing and stuff inside that. Even if like the outputs don't really make sense to be in the user interface, maybe they're going off to some other application, that would still work. Yeah, and also all this stuff works as an API too. So you can hit any of these spaces or any Gradio application that you're running locally or on your own remote server, even if you're not using spaces, you can hit it as an API. So if you want that queuing functionality, but you don't really need the interface because you're doing something like that where you don't really care about the outputs, you can hit it as an API as well. Cool. Anybody else? All right. Beautiful. Okay, cool. I think we're
Cool.
good.
Thank you so much, Nate.
Yeah, no
That's
problem.
awesome.